Let's just dive right in. Let's just say we are given this trinomial here that is 6x squared plus 11x plus 3. And I want to factor it. So you will see that I already have two things drawn on my paper or on my screen here. So I have a 2x2 box, okay? And I also have an x drawn. So I'm going to place the first term in the first box here, so 6x squared, and then I'm going to place the last term, which is 3, in the bottom right box. Okay, so then I want to multiply my first term times my last term. I'm just going to come off to the side here and write 6x squared times 3. And I like to go ahead and write the x squared with it as well, because it kind of reminds you that you'll see here in a little bit why, but it reminds you ones that you need to multiply and ones you need to add. So 6x squared times 3 gives me 18x squared. And then I'm going to place my middle term, and notice I also circled the plus sign there. I'm going to place that down here, 11x. And so the reason why I have this is because now I can be thinking to myself, I need to find two numbers, or two terms really, that when multiplied, they will be 18x squared, but when added, they will be 11x. And it's like solving a puzzle. Okay? And I find these to be fun because you have to kind of solve and figure out what these two numbers are going to be. So let's go ahead and list out the factors of this top number here, 18x squared. And I'm just going to start by listing 18. So 18 can be written as 1 times 18, or it could be 2 times 9, or 3 times 6, or 4, doesn't look like 4 works, does it? Okay, so I'm just going to cross that out. Or 5 times something, doesn't look like 5 goes into 18. Or 6 times 3 goes into 18. And you'll notice here, I can actually stop because I technically already have 3 times 6 and 6 times 3. Those are the same thing. Of these three numbers, or of these three combinations here, which ones add to give me 11? Okay, and you can hopefully see that it would be 2 and 9. So I'm going to write those two numbers here, 2x and 9x. And I always like to go back and just check and make sure I did this right. And you'll see why we wrote 18x squared here in just a second. So 2 times 9 is 18, and x times x is in fact x squared. And then when I add 2 plus 9, I do get 11. And because I'm adding like terms, this does not become x squared, it's just x, right? Okay, because they are like terms, I can add those. Okay, so now I'm going to go back to my box. And you'll find that the more and more of these that you do, the quicker it's going to become. But this is just a great pattern to be able to follow. So let's go back to the box, and I'm going to place 2x here and 9x here, and it doesn't matter which order you place them in. If I wanted to, I could have put 9x in this box and 2x in this box. It doesn't matter because it's still going to work out. Okay, so now I'm going to zoom in to this box here, because I always look for the GCF of the easiest pair to find. So to me, this sticks out to me right here, 6x squared and 2x. So what's the GCF of 6 and 2? So the biggest number that goes into 6 and 2 is going to be a 2. And the biggest variable that goes into x squared and x, my rule here is that you always look for the variable with the smallest exponent. And technically here you have an x to the first. So since that's the smallest exponent between x squared and x, I'm going to put an x here. So the GCF of 6x squared and 2x is 2x. Now, what's nice about this method is that you can, you could, if you wanted to, find the GCF of this column and put it here, and this column and put it here, and this row and put it here. It will work. It will all work out, and I'll show you how that works in a second. But what's nice about this is why it reminds me of a puzzle, and it becomes kind of fun for me, because I just like to think, okay, what times 2 gives me 6? Okay, well, 3 times 2 gives me 6, so this is going to be a 3. And what times x gives me x squared? Well, x does. Okay, so now let's move on to this one right here. What times 2 will give me a 2? Well, a 1 does. Okay, and what times x gives me x? Well, I can't multiply by another x, right? I can't do that because that would give me x squared. So I'm just going to leave this as a 1. And so I like to double check. 2x times 1 is in fact 2x. Okay, now let's go to this last part right here. So how do we find this one? Okay, well, what times 3x will give me 9x? Okay, or let's just talk about the numbers first. What times 3 gives me 9? Well, 3 does. Okay, and because I already have an x here, I don't put another x there. Okay, just the number here. So, and I always like to check. 3 times 3 is 9, and 3 times 3x is 9x here. Okay, and then lastly, I always like to double check this. 3 times 1 does in fact give me 3. And it will work out. Okay, your entire box will work out. This is why I like to think of it as a puzzle, because the GCF of 9x and 3 is 3. The GCF of 6x squared and 9x is 3x. Okay, the GCF of 2x to the first and 3 is 1. Okay, it will all work out. And then these are your factors. Okay, so if I were to ask you to factor this trinomial, you could use this method here, and your final answer would be 2x plus 3. Okay, so notice I kept, because this 3 is not a negative, it's a positive 3 here. Okay, and then the same thing up here, 3x plus 1. And those are your factors, and that is how you factor a trinomial. I have yet to find a trinomial that this method does not work on, and this is the reason why I like to use it, because I know I can rely on it to work every time. And if it doesn't work, usually it's either one, you might have made a mistake, or two, it's not factorable. But hopefully this helped you. If it did, please consider liking or subscribing, or leaving a comment on how it helped you. And if there's anything else that you need help with understanding, please leave a comment asking, and that'd be great.